the bouncing back of sound after striking a rigid surface in the same medium is called reflection of sound. So it is just same as the reflection of light. So whenever any incident light falls on a smooth or a plane surface, it gets reflected in the same medium, and the angle subtended between the incident light and the normal was angle of incidence. The angle subtended between reflected light and normal was angle of reflection. So same here, there is an angle of incidence and angle of reflection in case of sound. So hello students, so this is the continuation video of the chapter sound. So in the previous class we have come across the basic terms of sound which we have already learned in our junior classes, that is sound produced by vibration. So wherever there is a vibration, there is a production of sound, right? So also we have come across the definition of reflection of sound. We have come across this echo. So how this echo is formed? So it is a repetition of a substance or the repetition of sound when it falls on a rigid surface. So when this reflected sound gets repeated again and again, so there is a formation of an echo. So this echo also has certain conditions, that means the surface through which it is getting reflected should be rigid enough, should be at a minimum distance of 17 meter, and this original sound which you are sending in order to get reflect, that should have a optimum intensity. So these are the few conditions, and the reflected object should be also having a large enough. Okay, so these all are the conditions which I have already explained in my previous video, right? So you see the uses of echoes, we have seen it is used by sonar, that is sound navigation and ranging purpose, in order to calculate the depth of the sea. So we have solved few numericals also, and I have given you homework also. So I think you have done it in your exercise book. If it is not done, so make sure it's been done, right? So these notes are also you need to write in your exercise book. So this echo is being used by birds, it's being used by dolphins, fishermen. Also it's used in radar, that is radio detection and ranging, in order to send the radio waves. And the formula which is used to calculate the depth of a sea or the speed of light, that is d equals to c into t by 2, where d is the depth or the distance, c is the speed of sound, and t is the time, right? So this is the formula. Free or natural vibration. So in case if you are tying a string, it is clamped on one side of a wall. Let us consider this is the wall, and you have clamped a string along with the wall, and if you make to rotate or vibrate this string by holding one end of that string, then you will find that the string is getting vibrated. So the vibration is said to be here as natural or free vibration. Okay, so itself it vibrate after removal of the deforming force. That means once you have vibrated, now it is going on vibrating by itself, so it vibrates by a natural frequency. So you see what is free or natural vibration? When a body which is clamped at one point is displaced or disturbed from its position of rest, it starts vibrating. Such vibrations are called here natural vibration. So the natural vibrations and the free vibrations both are same here, right? And the frequency by which an object starts vibrating naturally, that is called here natural frequency. Now you see what are the conditions of here as free vibration and natural vibration. So when an object is vibrating in a given medium, if the amplitude of that vibration remains same throughout the time, then we can consider it to be as natural vibration. But in practical life, we don't get any object which is vibrating naturally, right? So eventually its strength gets decreased and its amplitude has to decrease. Now if the amplitude remains same, then it is said to be as free or natural vibration. That is means it is an ideal case. So if there is no participation of any other force or any disturbing element, then the amplitude will remain same. So that vibration of an object is said to be as natural vibration. That means the amplitude remains constant here, right? Now when I say the damped vibration, that means the periodic form or the periodic decreasing of amplitude of an object or that wave is said to be as damped vibration. That means we say the periodic vibration of decreasing amplitude. Now the amplitude is getting decreased, so eventually it is getting stopped. That means the vibration stops after a instant of time. So that vibration or that type of vibration is said to be as damped vibration. Now examples where we find this natural vibration, that means you can find in the pendulum, right? When you pluck the string of a guitar, the you see the strings get vibrated itself, so producing a natural vibration, but eventually it gets stopped again, that it forms the damped vibration. So this is the free vibration or the natural vibration. So free vibration of constant amplitude can occur only in a vacuum, therefore they cannot be realized in practice. So in a vacuum there won't be any other force, so we can get the constant amplitude. But if you see in presence of air, then as I have told, you will not get a constant amplitude. The amplitude will start decreasing periodically. So applications of natural vibration we may find in our vocal cord when we are speaking. So it's also been seen in the strings of this guitar. In an oscillating pendulum, when suspended freely, produces natural or free vibration. So these are the applications of natural vibration. This is the displacement time graph for the damped vibration. That means displacement is plotted in y-axis and time in x-axis. As you can see in the screen, the amplitude gets decreased. So the vibration of tuning fork, vibration of simple pendulum in air, vibration of a string instrument in air, a thin branch of tree when disturbed from the mean position, it executes damped vibration. So these are the differences between free vibration and damped vibration. So the main difference between free and damped, that is the amplitude remains constant and the vibration continue forever, that is in free vibration. And in damped vibration the amplitude decreases with time and ultimately vibration ceases, that means it stops. Vibration in free vibration, no energy loss in vibration. In damped vibration there is some loss of energy as heat in this vibration gets lost. Okay, so in free vibration there is no loss in energy, that is in free vibration the energy loss is minimum. In free vibration no external force acts on vibrating body, but in damped vibration frictional or damping force opposes the motion. And in free vibration the frequency of vibration is equal to the natural vibration of the vibrating body, and in damped vibration the frequency of vibration is less than the natural frequency of the vibrating body. So these are the differences between free vibration and damped vibration. Next topic we have force vibration. So whenever you are vibrating an object that is forcefully or apart from its natural vibration, then we say to be as force vibration. So when a body is made to vibrate with a frequency other than its own frequency, so if an object is vibrating other than its natural frequency, then that vibration of an object is said to be as force vibration. Okay, so you see this force vibration, when it matches with the natural vibration, then we say to be as resonance condition has formed. Like for example, so before going to a concept of resonance, let's see. So what is the meaning of resonance here with an example? So when you are sitting inside your house, sometimes you feel that the window panes starts vibrating. So they vibrate when an helicopter or any aeroplane just passes by or above your home, right? So when it passes, it sends a frequency, sound frequency, and when the sound frequencies matches with the natural frequency of your window pane, so both gates starts moving and they vibrate with higher amplitude. So similarly, a marching troops are asked not to, or they are asked to break their steps while passing through a bamboo bridge. I think you have heard this, right? So in armies and in soldiers, when the marching troops, when they march through a bamboo bridge, they are asked to break their steps, because there will be a formation of resonance and the bridge might collapse fast. Okay, so the frequency of the left and right, that motion of their legs, and the frequency, the natural frequency of the bridge, when they matches, they vibrate with higher amplitude and therefore it may collapse. So that is the condition of resonance here. So we will see what is resonance. When a vibrating system makes another system of the same natural frequency to vibrate, the systems are said to be in resonance. Now what are the conditions of resonance? First condition you can see in your screen, that is they should be of same frequency, they should have same phase difference, the angle made by the waves should be 0. So first condition, I think it is clear, they should have same frequencies, that means the natural frequency and the force frequency should match each other. Second, they should have a same phase difference. We know whenever a sound waves move, they form, you see, compression and rarefaction, or the crest or trough. When both the waves crest matches with each other or trough matches with each other, we say that they are in same phase. That means if the vibrating particle of that wave are in same locus or same origin, then we say that they are in same phase, or phase difference is 0. Next, the angle made by the waves should be 0. That means both the waves should be traveling in the same medium, that is parallel orientation. That means waves should have a parallel orientation. So in your screen you can see the differences between the free vibration and the forced vibration. This all you need to write in your exercise book. I hope you have brought your books. If not, I will be giving the pictures of the textbook also in your WhatsApp group, right? So you need to keep your exercise book update. And very soon I am going to conduct the online test also, so be prepared for that. Next topic, you see application of forced vibration. So in case of string instruments, when the string is struck, the hollow box providing them undergoes the forced vibration at the string frequency, thereby increasing the volume. That means actually what is said here, you see in the guitar or in a violin, you will find a hollow or vacant space. So when the strings of a guitar are being struck or when it is plugged, you see it vibrates with, and that vibration creates a vibration of the particles inside that hollow box, and thus there is a condition of resonance takes place and the amplitude gets increased. In case of reed instruments also is being used, like saxophone, vibration of the reed make the air column on the vibrate inside the instrument, which ultimately amplifies the sound. So same concept is being also used here, the forced vibration. So this is resonance, which is a phenomenon when the frequency of applied periodic force is equal to an integral multiple of natural frequency of the body, such that it readily takes up the vibration and begins to vibrate with an increased amplitude. So you can write the definition which I have shown in the board also. Conditions of resonance: they should have same frequency, they should have same phase difference, the angle might be made by the wave should be 0. That means they should have a parallel orientation, as already I have said. So this is an activity which shows the formation of resonance condition. So you see there are 4 balls, that is A, B, C, D. So when you apply a force in one of the ball and that balls collides with the other, and this collides with the next, this collides with the next, that means likewise you will find there will be a formation of resonance among these balls. So the difference between forced vibration and resonant vibration is also shown in the screen. So resonance can be found in a tuning fork, resonance can be found in the frame of motorcycles, which vibrates violently when it is driven at some particular speed. So these are the examples of resonance. And applications of resonance, that is resonance is used extensively in electronic circuits for tuning or phase matching. Resonance is used in radio and television receivers also. So in the wind box or the hollow box provided in the string instruments also is being used. It is used in various toys which is being constructed to respond a particular word of command of the whistle. So these are the applications So you need to write the exercise questions also based upon this topic, natural vibration, that is today's topic, whatever I have taught. So I will be giving the picture of this page also in your WhatsApp group. Characteristic of sound. In class 9 we have come across, that is pitch or shrillness or loudness and quality. That is pitch, loudness and quality. These are the three characteristics of sound. Pitch depends upon the frequency of the sound, loudness depends upon the amplitude, and quality or timbre depends upon the waveform of the sound, right? So these are the three characteristics of sound which we have already learned in class 9. So without going much detail and just skipping this portion, just you can find here the displacement and the time graph. You see this graph is said to be as having a high pitch, that is having a high frequency, and next one having a low frequency, that is low pitch. So you note here, when I said the high frequency, that means that the time gap is very minimum, but when the time gap is maximum, we said to be as low frequency. That means time is inversely proportional to frequency here. So a female voice is much shriller than that of male voice. Similarly, the loudness or intensity depends upon the amplitude. So in the first graph, that is A, having a small amplitude, having a soft note, and if it has a large amplitude, then we say that having a high note, or that is loud note. So loudness or intensity depends upon the amplitude. I asked what are the factors upon this loudness of sound depends. First, it depends upon amplitude. So higher the amplitude, more will be the loudness, and vice versa. Also it depends upon the size of the vibrating body. A small bell will definitely produce a small sound, whereas a large bell will produce a large sound. That means it depends upon the surface of the vibrating body. And also it depends upon the distance, that means inversely proportional to the square of distance. And next it depends upon the density of the medium. Okay, so these are the 4 factors upon which the loudness of sound depends. So unit of sound is here, loudness you can consider here decibel, that is if the bigger unit bell is used, okay, smaller unit we use decibel. So the unit of loudness is named after Bell to the honor of the scientist, that is Alexander Graham Bell, who invented telephone, right? So in order to honor this scientist, the unit has been kept. The last one, that is the quality or timbre, that means it depends upon the waveform. Noise and music, that means a regular or repetitive pattern which gives us a soothing sound that forms a music, and irregular pattern of vibration forms a noise. The sound level that is above 120 decibel is considered to be as noise, and whereas below 120 decibel is said to be as music. So you can see the differences between noise and music in the screen. So this also you need to write in your exercise book, and this exercise questions based upon this. So for this video only this much. So this sound chapter gets over, so we need to write this exercise book and be prepared for your coming online test. So all the best.